This video is about solving trigonometric inequalities. This is AP Precalculus topic 3.10. If you appreciate this content, please give it a like. If you have not yet memorized these 9 trig facts, please pause the video and memorize the chart right now. Number 6. What are all values of theta on the interval from 0 to 2 pi for which 2 cosine theta minus 1 times sine theta plus 1 is less than 0. When we have a more complex trig expression like this one, we use a sign chart. So let's label the left side of the inequality as f of x and make an f of x sign chart. The first step is to find where f of x is equal to 0. We will use the zero product property and set each of these factors equal to 0. Setting the first factor equal to 0, I'm going to do some of this in my head. So we have cosine theta is equal to, and once we set this equal to 0, we would add 1 to both sides and then divide by 2. So that will give us cosine theta is equal to 1/2. Small correction, I should have called this f of theta, not f of x. Anyway, we can find the reference angle by asking cosine of what angle is equal to 1/2. We have memorized that the cosine of pi over 3 is 1/2, so pi over 3 is the reference angle. On the interval from 0 to 2 pi, here are the 4 angles with a reference angle of pi over 3. We are looking for where cosine is equal to positive 1/2, so we will stick to quadrants 1 and 4, where the x value, and thus the cosine, is positive. The angle in the first quadrant with a reference angle of pi over 3 is pi over 3 itself. We can think of 2 pi as 6 pi over 3, so this angle in the fourth quadrant is 5 pi over 3. So these are the first 2 values that will go on our sign chart later. These came from setting this first factor equal to 0 and solving. But we have another factor. So if we set sine theta plus 1 equal to 0, we're going to end up subtracting 1 from both sides. So that will lead to sine theta is equal to negative 1. So where is the y value, the vertical displacement, equal to negative 1? Well, right here at the beginning, the y value is 0. As we rotate to this position, the y value is positive 1. At this position, the y value is 0 again, and when we rotate to here, the y value is negative 1. So this angle is 3 pi over 2, and this is where the vertical displacement, the sine, is equal to negative 1. So theta equals 3 pi over 2. This is a third value that we will use to make the sign chart. Be sure to label your sign chart as f of theta. You will need a row for each factor. So we need a row for 2 cosine theta minus 1 and another row for sine theta plus 1. Across the top of the sign chart, you should begin and end with the domain limitation. So we start with 0 and end with 2 pi. Include that. In between the domain limitations, you will have these 3 critical values in order from least to greatest. So you begin with your pi over 3, and then rotating clockwise, we get to 3 pi over 2, and then finally 5 pi over 3. Pay attention to which of these critical values came from which factor. So notice that when we set the first factor equal to 0, the 2 cosine theta minus 1, that's what led to the critical values of pi over 3 and 5 pi over 3. So these are the only places where this factor might change signs, pi over 3 and 5 pi over 3. That means that later, when I'm trying to use test values to figure out whether 2 cosine theta minus 1 is positive or negative, I don't have to check all 4 intervals. I only have 3 intervals, left, middle, and right. Looking at the other factor, the sine theta plus 1 led to this solution. So sine theta plus 1 is equal to 0 at 3 pi over 2. So this is the only place where this factor might change signs. So I don't need to check 4 intervals, I only need to check 2, left and right. So let's start with this first factor. I want to know whether 2 cosine theta minus 1 is positive or negative in this first interval. Since 0 is not a critical value, 2 cosine theta minus 1 is not equal to 0 at 0. I can use this as a test value. It's okay. So if I plug in 0 for theta, cosine of 0 is 1 because cosine is the x value, and at 0 the x value is 1. So we have 2 times 1 minus 1, which is positive 1. So all that matters is that this factor is positive in this interval. In the middle interval, we can use 3 pi over 2 as a test value. This is not one of the critical values for this factor. So at 3 pi over 2, the x value, the cosine, is 0. So I have 2 times 0, which is 0, minus 1. So that's why this factor will be negative in both of these intervals. We can use 2 pi as a test value again in this final interval. 2 pi is going to work just like 0 because we're at this same position. So for the same reason we got a positive when we plugged in 0, we will get a positive when we plug in 2 pi. Now look at the sine theta plus 1 factor. In the first interval we can use 0. If we plug in 0, so we have the sine of 0, sine is the y value, and the y value is 0 right here. So that'll be 0 plus 1, which is positive. So this factor is positive in this interval, plus plus. As we move on to the second interval, the right-hand side, well, guess what? We can use 2 pi. And that's going to have the same result as plugging in 0, because the y value is again 0. So that will still give us plus plus. What about the overall sign of f of theta? A positive times a positive is a positive. A negative times a positive is a negative. Same thing here. A negative times a positive is a negative. And a positive times a positive is a positive. We were looking for where f of theta is less than 0. So focus on these intervals where f of theta is negative. So we are going to use open circles. Okay, I like to record my solution on the number line first. And f of theta is equal to 0 right here. And we don't want or equal to 0, just less than 0. So we're going to leave this solution out using an open circle. F of theta is also equal to 0 at 3 pi over 2 because sine theta plus 1 equals 0 here. See the orange line? So this point has to be left out with an open circle as well. Same thing for 5 pi over 3. F of theta is equal to 0 here because 2 cosine theta minus 1 is equal to 0 right here. So that reminds me that I'm going to have to record my solution using 2 intervals from pi over 3 to 3 pi over 2, union 3 pi over 2 to 5 pi over 3. I cannot just say pi over 3 to 5 pi over 3 because that would include one value where f of theta is equal to 0, and we don't want that. Here's your final answer in interval notation and as an inequality. Number 7. What are all values of theta on the interval from 0 to 2 pi for which sine squared theta times 2 cosine theta minus radical 2 is greater than or equal to 0? As before, let's call the left side of the inequality f of theta, and we're going to make an f of theta sign chart. To make an f of theta sign chart, we need to find where f of theta is equal to 0. Since it is already written in factored form, we can set each one of these factors equal to 0 and solve. So let's start with sine squared theta is equal to 0. Taking the square root of both sides unsquares this, but then the square root of 0 is still 0. So we end up with sine theta is equal to 0. Sine is the y value on the unit circle, and y values are equal to 0 at this position and this position. That is 0 and pi. So these are the first two critical values we will include on the sine chart later. Now let's set the second factor equal to 0 and solve. I'm going to do a little of this in my head. We would add radical 2 to both sides and then divide by 2. So we get cosine of theta is equal to radical 2 over 2. You can find the reference angle by asking yourself the cosine of what is radical 2 over 2. We have memorized that the cosine of pi over 4 is radical 2 over 2, so that means pi over 4 is the reference angle. On the interval from 0 to 2 pi, here are the four angles with a reference angle of pi over 4. Since we want cosine to equal positive radical 2 over 2, we will stick to quadrants 1 and 4, where the x value and thus the cosine is positive. In the first quadrant, the angle with a reference angle of pi over 4 is pi over 4 itself, and we can think of 2 pi as 8 pi over 4, which means this angle in the fourth quadrant is 7 pi over 4. So here are two more critical values that we will use to build the sine chart. Be sure to begin and end your sine chart with the domain limitation. So start with 0 and end with 2 pi. Always label your sine chart as f of theta and make a row for each factor. Record your critical values across the top on this number line. Be careful, 0 is one of the critical values. It's a critical value of sine squared theta. So even though it is the beginning of the domain, the limited domain, it's also a critical value. So it's there. We also then have pi over 4, and then we have pi, and then we get to 7 pi over 4, and then we get back to 2 pi. 2 pi, like 0, is going to be a critical value of sine theta. So I like to mark the vertical lines that represent the critical values that correspond to each factor. So sine squared theta was equal to 0 at 0 and pi. So I'm going to put a vertical line, an orange mark at 0 and pi. But be careful, I'm also going to put it at 2 pi. Because of course, if I go all the way and back around to 2 pi, I'm at that same position. The y value is also equal to 0 at 2 pi as well. So that's going to be a critical value. These other critical values of pi over 4 and 7 pi over 4 came from the second factor. So I'm going to put my orange mark here and here. Now we have to decide whether these factors are positive or negative in each interval. This top row is very easy because we have something squared, which will be positive in every interval. If you take something negative and square it, it becomes positive. So what about this one? We only have 3 intervals to check. In the first interval, 0 is not a critical number. So I can plug it in. It's not going to give me 0. If I plug in 0, cosine of 0 is 1, because at 0, the x value is 1. So this is really 2 minus radical 2. Radical 2 is something smaller than 2, so this is going to be a positive number. Plugging in 2 pi will give me the same answer as plugging in 0, so I don't really have to think about it again. If I got positive at 0, I will get positive at 2 pi. On this middle interval, I can use pi. So if I plug in pi for theta, I have the cosine of pi. At pi, the cosine, the x value, is -1. So I have 2 times -1, so this will be -2 minus radical 2. So if I take something that's negative and then subtract, I'm definitely going to get a negative number. So this factor will be negative in this interval. What about the overall sign of f of theta? Well, a positive times a positive is a positive times a negative is a negative, a positive times a negative is a negative, and a positive times a positive is a positive. We were looking for where f of theta is greater than or equal to 0. So the solutions will definitely fall in these intervals where f of theta is positive. But what about the endpoints? We are looking for where f of theta is equal to 0 as well. And f of theta is equal to 0 at these endpoints. So we will include the endpoints with our answer. So we will have solutions between 0 and pi over 4. I'm going to use closed circles to show that the endpoints are included. When I write my interval notation in a moment, these will be brackets. And again, from 7 pi over 4 to 2 pi. Okay, these are the intervals where f of theta is either greater than or equal to 0. Here's your final answer in interval notation and written as an inequality. Actually, I messed up and left out one solution, so not so fast. Here's what we are missing. Remember that these orange marks were here to remind me where a factor is equal to 0, right? These were all critical values. But notice that we do have this orange mark right here at pi, where sine squared theta is equal to 0. And 0 times anything is going to be 0. So that means f of theta is equal to 0 right here at pi. That's another solution because we are looking for where f of theta is greater than or equal to 0. So we need to include pi in our solution set. In interval notation, we will add in a single value using braces. Technically, we use braces whenever we are just making a list as opposed to an interval. But a single value is like a list of 1. So we do use braces. And as an inequality, we will just say, or theta is equal to pi. So please be so careful. I'm betting this is going to be a common mistake to leave out these single values. So really watch out for it whenever you have an inequality that is something or equal to, greater than or equal to 0, or less than or equal to 0. Because that or equal to will include any of these critical values, even if it's just a single value like this one. Number 8. What are all values of theta on the interval from 0 to 2 pi for which 2 sine squared theta minus sine theta minus 1 is less than 0? Let's refer to this part of the inequality as f of theta. And we begin by finding where f of theta is equal to 0. So 2 sine squared theta minus sine theta minus 1 is equal to 0. We will solve this by factoring 2 sine squared theta can only be factored as 2 sine theta times sine theta. Skipping over to the third term, 1 can only be obtained from doing 1 times 1. Inner plus outer must equal the middle. Inner, I have 1 sine theta. Normally I do this in my head. I'm only showing this for instructional purposes. Outer, that's the product of these two, I have 2 sine theta. This needs to equal a middle of -1 sine theta. So that means we need +1 sine theta and -2 sine theta to make negative 1 sine theta. So that tells us that we need a positive here and a negative here. Also notice that positive 1 times negative 1 does equal negative 1. Once you have factored form, you set each factor equal to 0 and you solve. If I set 2 sine theta plus 1 equal to 0, I would subtract 1 from both sides and then divide by 2. So we will get sine theta is equal to negative 1/2. Setting sine theta minus 1 equal to 0, I'm going to add 1 to both sides. So I get sine theta is equal to positive 1. Let's start by solving the sine of theta is equal to negative 1/2. Ignoring the negative sign, we find the reference angle by asking the sine of what angle is 1/2. We've memorized that the sine of pi over 6 is 1/2, so pi over 6 is the reference angle. On the interval from 0 to 2 pi, here are the 4 angles with a reference angle of pi over 6. Since we want sine theta to equal negative 1/2, we will stick to quadrants 3 and 4, where the y value and thus the sine function is negative. We can think of pi as 6 pi over 6. So this angle in the third quadrant is 7 pi over 6. So that is one solution. We can think of 2 pi as 12 pi over 6. So this angle in the fourth quadrant is 11 pi over 6. So that's another solution. Now let's turn our attention to sine theta is equal to 1. Sine is the y value on the unit circle. I think I'll switch colors here. Right here at 0 radians, the y value is 0. And then as I rotate to this position, the y value is 1. As I rotate to this position, the y value is back to 0 again. And as I rotate to the bottom, the y value is negative 1. So the question was, where is the sine equal to 1? Well, that was at this position, which is pi over 2 radians. So that is going to be another critical value. So theta is equal to pi over 2. These are the 3 values that will go on our sine chart. Your sine chart should be set up like this. It should be labeled as f of theta, and you should have a row for each one of these factors. Also, you should have the beginning and end of the domain limitations labeled. So we are going from 0 to 2 pi. That should be here and here. In between, you have your 3 critical values where f of theta is equal to 0 in order from least to greatest. In addition, I want you to indicate which of these critical values came from each factor by highlighting it with a vertical line. If you're doing this with pencil and paper, you might just darken it in. So, for example, we recall that the first factor of 2 sine theta plus 1 gave us these two solutions, 7 pi over 6 and 11 pi over 6. So I'm going to trace these 2 critical values in orange for the first row. The second row, the factor of sine theta minus 1, gave us the critical value of theta equals pi over 2. So I'm going to highlight pi over 2 for the second row. This will help me because, for example, this first factor of 2 sine theta plus 1 can only change signs at 7 pi over 6 and 11 pi over 6. So I don't have to check 4 intervals. I really only have 3 intervals, here, here, and here. When I get to sine theta minus 1, it can only change signs at pi over 2. So I only have 2 intervals to check, not 4. Back to sine theta plus 1. I need to figure out whether this factor is positive or negative in this first interval. Because 0 is not one of the critical values of this factor, I can use 0 itself as a test value if I want. And that turns out to be really simple for this factor because the sine of 0 is 0. So I'm plugging in the 0. The sine of 0 is 0. 2 times 0 is 0. So that just leaves positive 1. So that means this factor is positive in this interval. Now I need to pick a test value between 7 pi over 6 and 11 pi over 6. Alright, that's between here and here. I see a nice value of 3 pi over 2. I think I'm going to write this one down though. Let me switch to purple. So plugging in the 3 pi over 2, we have 2 sine 3 pi over 2 plus 1. Sine is the y value on the unit circle. So at 3 pi over 2, the y value is negative 1. So this is going to be 2 times negative 1 plus 1. Well, this is negative 2 plus 1, which is negative 1. That tells me that this factor is negative in this interval. For the final interval, I can use 2 pi as the test value, but 2 pi works exactly the same way as 0. The sine of 2 pi is 0, just like the sine of 0 is 0. So, just like we got a positive in this first interval, we're going to get a positive in this interval as well. Now we turn our attention to sine theta minus 1. Again, we can use a value of 0 as a test value because it is not one of the critical values of this factor. It will not give me 0 when I plug it in, so it's fine. So plugging in 0, sine of 0 is 0, leaving the negative 1. So this factor is negative in this interval. What would be a good test value to use on the interval from pi over 2 to 2 pi? So that goes all the way from here, all the way back around to here. So I have many options to choose from. A good one to choose would be pi. So I'm plugging in pi right here. So I'm going to have the sine of pi minus 1. This is easy because sine is the y value on the unit circle. And right here at pi, the y value is 0. So this is 0. That's going to leave the negative 1, which means that this factor is negative in this interval as well. What about the overall sign of f of theta? A positive times a negative is a negative, so f of theta will be negative in this interval, and this interval. A negative times a negative is a positive, so f of theta will be positive in this interval. We are looking for where f of theta is less than 0. So the solutions will be in the intervals where we have the negatives. But before I mark that, I'm going to pay careful attention to the endpoints. So on this problem, we are looking for where f of theta is less than 0, not equal to 0. So all these points where f of theta is equal to 0, I'm going to put an open circle because these are not to be included. So I'm going to put an open circle here and an open circle here. And an open circle here and here. Wait, maybe not on the 2 pi. So these critical values are where f of theta is equal to 0. We want less than 0 but not equal to 0, so these have to be left out. However, I'm going to put a closed circle on 0 and 2 pi. Because these are not places where f of theta is equal to 0. These are not critical values. So f of theta is negative at 0. And it is actually negative at 2 pi. So these values should be included because f of theta is negative. It is less than 0 at these two values. So these values need to be included. So we want the intervals where f of theta is less than 0. So I'm looking at these negative intervals. So that's going to be from here to here, and from here to here, and from here to here. Let's write that up in interval notation. So this first interval goes from 0 to pi over 2. I'm going to put a bracket on the 0 to show that it is included, and a parenthesis on the pi over 2 to show that the pi over 2 is not included. And then I'm going to say union. And then here comes the next interval, parenthesis pi over 2 to 7 pi over 6 with another parenthesis. And then union again. And then we have the third interval from 11 pi over 6, which gets a parenthesis to show that it is not included, to 2 pi with a bracket to show that 2 pi is included. So one more time, let me just emphasize that a common mistake is that students will see that we have two negative intervals in a row, and we do want the values that cause f of theta to be less than 0. So they know we're looking for the negatives. Because we have back-to-back negatives, sometimes kids want to make just one big interval and say, well, let's do the interval from 0 to 7 pi over 6. Okay, the problem with that is that we are including a value pi over 2, where f of theta is not less than 0, it is equal to 0. And that's not allowed. So we do have to split it up into two intervals for a total of 3 intervals. And here is the same solution set written with inequalities. Hey guys, don't forget to like and subscribe, but also if you found this video helpful, there's a lot more where that came from. You can click the upper link, which will take you to the whole unit playlist, or you can click the lower link, which will take you to the next video in the playlist. See you there.